figure out how many ceiling fans you can run on a single 3-speed fan control, you need to consider two main things: the wattage of the fans and the wire gauge used in the circuit. First, let's talk about calculating the electrical load. The electrical load is essentially the total power that all the fans together will draw. To find this, you multiply the wattage of one fan by the total number of fans. For example, if you have 8 fans and each fan is rated at 60 watts, the total electrical load would be 8 times 60, which equals 480 watts. Next, you need to think about the wire gauge. The wire gauge is the thickness of the electrical wire, and it's important because it determines how much current the wire can safely handle. The correct wire gauge depends on both the electrical load and the length of the wire run from the fan control to the fans. For a load of 480 watts, a 14-gauge wire is often recommended. With a 14-gauge wire and a 480-watt load, you can generally operate up to 8 fans. However, it's crucial to remember that this is just a general guideline. You should always check the manufacturer's specifications for the fan control to make sure you don't exceed its maximum capacity. You also need to comply with all local electrical codes. Now, there are a few other things to keep in mind. The type of fan matters. Fans with direct current, or DC, motors usually use less energy than those with alternating current, or AC, motors. Also, the speed settings on the fan control can affect the number of fans you can safely operate. Another critical point is the circuit breaker or fuse that protects the circuit where the fans are connected. Make sure it can handle the total electrical load of all the fans. Let's break down these considerations further. When you are looking at the fan's wattage, check the label on the fan itself or in the product documentation. This will give you the power consumption of a single fan. This number is essential for calculating the total load. Now let's delve a little deeper into wire gauge. The American wire gauge, or AWG, system is used to measure wire thickness. Lower AWG numbers indicate thicker wires, which can carry more current. For instance, 12-gauge wire is thicker and can handle more current than 14-gauge wire. The National Electrical Code, or NEC, provides tables that specify the allowable ampacities for different wire gauges. These tables take into account the wire material, insulation type, and ambient temperature. When you are determining the appropriate wire gauge, consult NEC Table 310.15b16 or a similar table in your local electrical code. This table provides the maximum amperage that different wire gauges can safely carry. For example, a 14-gauge copper wire with type TW insulation is typically rated for 50 amps, while a 12-gauge copper wire with the same insulation might be rated for 20 amps. To choose the right wire gauge, you need to calculate the total current that the fans will draw. To do this, use the formula current, which is in amps, equals power, which is in watts, divided by voltage, which is in volts. In a standard 120-volt circuit, the current for our example of 480 watts would be 480 divided by 120, which equals 4 amps. Since 4 amps is well below the 15 amp limit for 14-gauge wire, it seems like 14-gauge wire would be sufficient. However, it's always a good idea to add a safety margin. Electrical codes often require that you size the wire to handle 125% of the continuous load. In this case, 125% of 4 amps is 5 amps, which is still within the capacity of 14-gauge wire. Keep in mind that long wire runs can result in voltage drop, which can affect the performance of the fan. If the wire run is long, you may need to use a thicker wire to minimize voltage drop. Voltage drop calculators are available online to help you determine if voltage drop is a concern in your situation. Fan controls also have a maximum wattage or amperage rating. This rating indicates the maximum load that the control can safely handle. Make sure that the total wattage of all the fans does not exceed the fan control's rating. This information is usually found on the fan control itself or in its documentation. As mentioned earlier, the type of fan can influence the electrical load. Direct current fans are generally more energy efficient than alternating current fans. This means that for the same amount of airflow, a direct current fan will consume less power. If you are using direct current fans, you may be able to operate more fans on a single control. Speed settings can also impact the load. When a fan is running at a lower speed, it consumes less power. However, some fan controls are not designed to handle multiple fans at lower speeds. Check the fan control specifications to see if there are any limitations on the number of fans that can be operated at different speed settings. The circuit breaker or fuse protecting the circuit should be sized appropriately for the load. A circuit breaker is a safety device that automatically interrupts the flow of electricity if the current exceeds a certain level. A fuse is a similar device that melts and breaks the circuit when the current is too high. The size of the circuit breaker or fuse is determined by the wire gauge and the expected load. For a 15 amp circuit with 14 gauge wire, a 15 amp circuit breaker or fuse is appropriate. It's crucial to avoid overloading circuits, as this can lead to overheating and potentially cause a fire. If you are unsure about any aspect of the fan installation, it is always best to consult with a qualified electrician. The electricians have the knowledge and experience to ensure that the installation is safe and code compliant. Moreover, local electrical codes can vary, so it's essential to be aware of the specific requirements in your area. These codes are in place to protect people and property from electrical hazards. To summarize, to determine the number of ceiling fans that can operate on a 3-speed fan control, firstly calculate the total electrical load by multiplying the wattage of each fan by the number of fans. Secondly, determine the appropriate wire gauge based on the electrical load and the length of the wire run, consulting NEC Table 310.15b16 or similar. Thirdly, ensure that the total wattage of the fans does not exceed the fan control's maximum rating. Fourthly, consider the type of fan, speed settings, and the capacity of the circuit breaker or fuse. Fifthly, consult with a qualified electrician if you have any doubts or concerns. By following these steps, you can ensure a safe and efficient ceiling fan installation. The NEC, or National Electrical Code, plays a significant role in ensuring electrical safety. It sets the standards for electrical installations in the United States. It's important to be aware of the NEC requirements in your area and to follow them carefully. The NEC is updated every 3 years, so it's a good idea to stay current with the latest edition. Some key NEC sections that relate to ceiling fan installations include Article 430, which covers motors and motor circuits, and Article 314, which covers outlet boxes and conduit bodies. These sections provide detailed requirements for wiring, grounding, and overcurrent protection. In addition to the NEC, local electrical codes may have additional requirements. These codes can vary from city to city or county to county. It's important to check with your local building department to find out what the specific requirements are in your area. When you are installing ceiling fans, it's important to use the right tools and equipment. This includes wire strippers, pliers, screwdrivers, and a voltage tester. Always turn off the power to the circuit before working on any electrical wiring. Use a voltage tester to verify that the power is off. When you are making wire connections, use wire connectors that are appropriate for the size and type of wire. Make sure that the connections are tight and secure. Grounding is an important safety measure that helps to protect against electrical shock. Make sure that all of the fans are properly grounded. The grounding wire should be connected to a grounding screw in the outlet box and to the grounding terminal on the fan. After you have installed the fans, test them to make sure that they are working properly. Check the speed settings and make sure that the fans are not vibrating excessively. If you notice any problems, consult with an electrician. Proper ventilation is essential for ceiling fans to operate efficiently. Make sure that the fans are not blocked by furniture or other obstructions. The blades should be able to rotate freely without hitting anything. Regular maintenance can help to prolong the life of your ceiling fans. Clean the blades periodically to remove dust and debris. Check the screws and bolts to make sure that they are tight. Lubricate the motor if necessary. When selecting ceiling fans, consider the size of the room. Larger rooms require larger fans. The fan should be sized appropriately for the room to provide adequate airflow. The height of the ceiling is also a factor to consider. If the ceiling is low, you may need to use a low-profile fan. Fans with longer blades typically move more air than fans with shorter blades. However, longer blades may not be suitable for smaller rooms. The style of the fan should complement the decor of the room. There are many different styles of ceiling fans available, from traditional to modern. Consider the energy efficiency of the fan. Energy-efficient fans can save you money on your electricity bill. Look for fans with the Energy Star label. The location of the fan control should be convenient and accessible. The control should be located near the entrance to the room. Consider using a remote control for added convenience. Remote controls allow you to adjust the fan speed and turn the fan on and off from anywhere in the room. Smart fan controls are also available. These controls can be integrated with your smart home system and can be controlled with your smartphone or voice assistant. When you are installing ceiling fans in a church sanctuary, there are some additional considerations to keep in mind. The fans should be quiet so that they do not disrupt the service. The fans should be aesthetically pleasing and should complement the architecture of the sanctuary. The fans should be installed in a way that does not interfere with the lighting or sound system. Consider using a professional installer who has experience installing ceiling fans in churches. They will be able to ensure that the fans are installed safely and properly. When determining the number of fans, consider the airflow requirements of the space. The fans should provide adequate airflow to keep the sanctuary comfortable. You may need to install multiple fans to achieve the desired airflow. Consider the weight of the fans. The ceiling structure must be able to support the weight of the fans. You may need to reinforce the ceiling structure to support the fans. Consider the height of the ceiling. If the ceiling is high, you may need to use extension rods to lower the fans to a more accessible height. Consider the placement of the fans. The fans should be placed in a way that maximizes airflow and minimizes drafts. Consider the control options. You may want to use a single control to control all of the fans, or you may want to use separate controls for each fan. Consider the energy efficiency of the fans. Energy-efficient fans can save the church money on its electricity bill. Consider the maintenance requirements of the fans. Choose fans that are easy to maintain. Consult with a qualified electrician to determine the best way to install ceiling fans in a church sanctuary. They will be able to assess the space and provide recommendations based on your specific needs. Remember to obtain all necessary permits before starting the installation. Electrical work typically requires a permit from your local building department. Be sure to follow all local electrical codes. These codes are in place to protect people and property from electrical hazards. Proper installation of ceiling fans is crucial for safety and performance. Taking the time to plan and execute the installation carefully will ensure that the fans operate efficiently and safely for years to come. Always prioritize safety and consult with qualified professionals when needed.